For this tutorial, I will demonstrate how to build extinguishing equipment. Firstly, we have equipment and the tools. This is a cross draw driver. This is a relay, and we have a flame sensor. We have micro bit. We have the breakout board. This is a breadboard, and this is a fan and a DC motor. And we need several wires and 3 F2M wires. So let's start. I'll show you the wiring image, which is how to connect the wire to each of the model and the breadboard. So firstly, we connect the flame module. This is a flame sensor. Let's go. As you see here, it has a VCC GND. VCC is a positive port and the GND is a negative port. And we use another AO, which is analog output, analog voltage output. So let's connect. We connect microbit to its breadboard, and the holder which is provided by the vendor. If you don't have, doesn't matter. You can use yours. It has a lot of different version breadboard, but all are good. Like this. So we have the sensor. Now we connect the VCC to positive port and the GND to the negative port. The AO, as we said, is the analog voltage output. So this is output. This is to output a signal, which is like when the sensor detects the fire or flame, it outputs a signal to the microbit, and it receives the signal, then do the other operations. So we connect to the PO port. It depends. I just use a PO to receive the signal. Here's PO. And I'll show you whether you can see clearly. So it's down. And we use this one is called relay. It's just like a switch to to control the fans, control the motor. We use a straw driver to screw it. We do the switch only for open or close the fans, stops the motor. So we don't need another option to control another one. So we just need to connect these two ports regardless of the another one. It's okay. But if you wanna do the rest operation, you can link this port via the wire to another. Like, I'm not sure what we can do for here, but it's okay if you want. So we're done, and we make connection. For here is DC plus and DC minus, which means the negative and the positive and the negative port. We link the positive port to the positive in breadboard, and negative to the negative port. For another one we call the signal port. Here is in IN, which is input. So we connect to the P1, or we can use other ports. Other ports is okay. I use P1. So for here, we need another 2 wires to connect the 5 voltage port to the positive in our breadboard. So make it power. So we connect GND to negative. For the last stage, we just need to connect the relay to our motor. So it's hard. So for the relay, it has a COM. The COM is like a switch from it's default switched on the NC, and if it receives a signal to trigger the motor, it will switch on to NO, which is this side. So we link the NO to our motor. And we link the CMO to the negative side. And here for the motor, another port, we link to positive. Since I have already read my code, load my code in my microbit, so it can work right immediately. Let's try this fire. Oh no. Yeah, it detected like this, as you see. Yeah, works good. So, yeah, just something like this. Level 1, I will show you how to build the extinguishing equipment. So right now I'm showing the wiring diagram. This is a flame sensor, this is a relay module, this is DC motor. So we firstly connect to the microbit extension board to our breadboard. So we connect 5 voltage to positive port, and the GND to negative port. So here everything we connected VCC to positive and GND to negative, same as here. So for the flame sensor, we use the AO, which is the analog voltage output. So we connect to P0. So when a flame signal received, it will pass to P0, and that microbit to do the other operation later. So it sends the signal to the microbit. Microbit will decide what signal will send to what operation sent to the module. So from P1 to module. And module is like switch. It will default to link to this one, but we don't use this side. So for when it receives a signal from the microbit, the switch will turn to this one. So we link them together, module to positive side and the module to negative side. So then they link together. So let's see how to code. We did all of them. Restart. For what we start, we have a on start and forever. We start from a variable which called flame I already have. So we set a variable set flame to 0, which means the signal is start from 0 at the start. So when we need a if else statement. Yes, if what, then we trigger the relay module, trigger the motor. So what it means, we can pass the signal to 1, and what statement, what else we can use, make it to 0, do not pass the operation. So what's a condition? Since we use AO, it's called analog voltage output. So when when sensor receive a signal, it pass to a P0. What it means? It means it means it receives a signal. So we have analog. We have to read an analog signal. So from here, we have analog P0. We just drag it out. So we need it has a value. It has a value. What it means? It has a value when it be the darkness. The value is turned to be infinity. And when it detects a fire or a flame, the value to be smaller. When fire is very strong, it tends to be 0. So we need a logic and we need a comparison. So if the signal received and the value less than what value, then trigger the model. So the value we tested to be 800. You can have a more appropriate value if you're gonna do further testing. So we can have a pause, make it. Then we have another forever, which means when we have if else statement. So when flame to be 1, I'll write for you what to be 1. When the flame the variable be 1. Now string. Okay. Then we create a LED like this, and we flash the LED. What's wrong with it? I don't know. I create another one. Let's try. And we first make the trigger. So we write P1, this one, P1 here. You want P1? Yes. Else we have LED not show anything. So trigger to be 0. What's wrong with here? So if something equal to 1, oh yeah, I write the string. If flame equal to 1, then do this stuff. So that's done. We download it and we done. Thank you for watching.